Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our by file methods of numerical integration. We're going to start with our left rectangle by file. The difference being with these functions is instead of using a mathematical function like y equals to f of x to calculate the values associated with the numerical integration, we are instead going to use a CSV file or comma separated values of x and y values to calculate the area under a curve. This video is part of a larger series of videos focusing on numerical methods and specifically a numerical demo. And for this sequence, we are looking at numerical integration. This video also assumes that you have watched the videos that set up the main and triaging our switches, as well as the functions, left rectangle by function, and the similar functions associated with it. Now, the first thing that I want you to do is notice that I've made a slight change in the function signature. It does not affect the functionality, but rather it is just meant to be in line with the other videos. In particular, what I've done here is I have just changed over to where I have a char constant vector or array for my file name. Now, without further ado, let's go ahead and jump into our function, left rectangle by file. And let's go ahead and pull up one of our sample input files. In this case, you'll see it's a 2-column CSV file with the first column representing the X value and the second column representing the Y value. I've provided a couple of these files for you, and also take a second to review the Wikipedia article associated with numerical integration to make sure that you are comfortable with the idea, particularly the idea that we are essentially summing up the area under a curve utilizing simply the length and width of a rectangle. Now, getting back to our function, since this is file-based, we are going to have to practice some of the methods that we've seen earlier with respect to reading data from a file. To begin with, the first thing that we want to do is we want to go ahead and set up our file pointer variable. So to begin with, we're going to set up a file input. Likewise, what we want to do is we want to go ahead and establish some temporary variables that we are going to need as we go along, much like the ones that we used in our earlier examples. And particularly what we would like to have is a x left and a x right variable. And we're going to go ahead and set up some additional variables that we may or may not use in this function. However, they will sort of give us a continuous feel between the other functions as well. And those I'm going to refer to as y left and y right. Now, we may need some additional variables as we go along, but this should roughly get us started. Now, to begin with, what we want to do is we want to simply read out the data from the file, recognizing that we are expecting a double data type. And so as such, we want to first open the file using fopen, verify that in fact we do have a valid file, and then start reading the data appropriately. To begin with, what we're going to do is we're simply going to read the data from the file and write it to the command line, just to make sure that we know what we're doing. So the first step that I want to do then is use our input file pointer, and I want to use an fopen, and I want to read the file name that is being provided to us in our function signature. And specifically, I want to open it for reading. The next step is we want to check to make sure that our input file pointer is not equal to null. If it is equal to null, that simply means that the file does not exist or that for some reason we do not have access to it. If that is the case, we simply want to print a message back to the user that indicates that there was a problem. In this case, I'm going to say error, unable to open file. And instead of just saying generic file, perhaps it would be a good idea to simply specify %s and then follow that up with the file name. Now, we could also consider having some additional logic prior to trying to open the file, particularly checking to make sure that the file name is actually a reasonable length, and optionally consider looking to see if it has a file extension. However, we're going to assume that in this case that the person sending, or the calling function sending the file name to this function, has done some initial validation, and that all we are going to do is simply check to see whether or not we can open it. Now, the first step we want to do is, if we have successfully opened the file, we want to make sure to go ahead and close it before we forget to do so. Now, at this point, what we want to do is we want to just simply prove to ourselves that we can read a 2-column file. And to do that, we are simply going to set up a while loop utilizing our fscanf function, and we're going to use our file input as the pointer, the file pointer. Next, we want to start playing around and figuring out if we can identify our format spec that we need. And I'm going to go ahead and start off with 2%fs, and I'm going to attempt then to place them in the x left and y left variables. So I'm going to use the address of x left and the address of y left. And if this is not equal to our end of file, then essentially what we're going to do is simply print out the values. And so in this case, what I'm going to do is I'm going to specify x equals and then %f, followed by a y equals and %f, followed by a new line, and then simply place in there the x left and the y left values. Now, note I may have accidentally included too many parentheses here, so I'm going to go ahead and eliminate those. And at this point, let's just go ahead and build it. This also gives us an opportunity to test to make sure that our switches are working early on, and we have the ability to correctly pass the file name. Now, before you go any further, you want to make sure that you do in fact have the input_01.csv and input_02.csv files in your folder along with your numerical demo. You can check that using either Windows Explorer or come to the command line and type in dir. And specifically, you can actually go so far as to type in dir input ***. And this will only display your input files. Now, moving forward, let's see if we've actually accomplished something. So what we want to do is we want to run our numerical demo. We want to run it in parametric mode. And specifically, what we want to do is we want to leverage our left rectangle. And we want to leverage the method by file. And now the only thing that we need to provide is one of our input files. So input_01.csv. And you'll see that we essentially are continuing to print and print and print. So we've got some sort of problem here that we need to take a look at. So I'm going to go ahead and hit Control-C. And at this point, then what we want to do is we want to take a look at why we have an infinite loop. Well, part of it stems from the fact that we did not use the correct format spec. So in this case, what I would like to do is I'd like to already go ahead and specify a comma in between our two pieces of data. I'm going to save it and I'm going to build it again. If we rerun it, you'll notice that now we do in fact get a finite number of values. In other words, our loop does not run indefinitely. However, though, we don't have any of the correct information in there. So once again, we want to go back and we want to take a look at what is going wrong here. And specifically what we did is we specified the wrong format spec. So in this case, we want to have %lf %lf. And once again, I'm doing this intentionally so that you can sort of go through some of the troubleshooting steps that you're going to encounter when you are working with a file. It's important to go ahead and set this up early so that you can establish some of the basics. In this case, were we able to successfully read data from the file? I'm going to go ahead and build it one more time. And if I hit my up arrow, you'll see that this time around, we have not only our loop runs a finite number of times, but it also has the same data that you saw in the file. So in other words, we can consider this a minor victory. Now, we want to think a little bit more about what we're actually trying to do here. And probably the first thing that would be helpful is to simply open up your input_01.csv in a tool like Excel or MATLAB. And in this case, I'm going to go ahead and open it in Excel so that we can see what in the world our data actually looks like. And what I'd like to do here is I'd simply like to graph the data. And in this case, what I'm going to do is I'm going to insert, and then under the charts, I'm going to insert a scatter plot. And specifically what I want to do is I want to plot my X against my Y. And you can see here, especially if we zoom in a little bit, that essentially what I'm going to try to do is I'm going to try to create a bunch of rectangles underneath this set of data that essentially approximates the area under this curve as if it were a continuous function. Now, the important thing to note here is that we are going to be using the left side of the rectangle, meaning that for every data point we have here, we can only calculate up to n-1 rectangles. Why? Because we're only going to be using the left side of the rectangle to be able to calculate the area under the curve. So essentially, this X left and this Y left are going to be used to calculate the area under the curve. If we were to use the last data point, there effectively would be a rectangle that would extend beyond our X max. So with that in mind, we have to figure out a way how to embrace the fact that we are essentially going to ignore this last piece of data. In other words, we want to continue to read the data, but our last rectangle is going to have a X min of 0.99, or rather an X left of 0.99, an X right of 1, a Y left of 0.0199, and a Y right of 0. Now, there are several ways that we can go about doing this. However, the way that I'm going to suggest in this video is hopefully going to be pretty straightforward. To begin with, what we're going to do is we're simply going to have an extra F scan F, meaning that we are simply going to read the data from the first line, and we are going to go ahead and put it into our X left and our Y left variables. So to begin with, I'm simply going to have an if F scan F input, and much like the lesson we saw earlier, the lesson we learned, we want to do %LF, comma, %LF, and simply store in that location of X left and ampersand Y left the values associated with that first line. And we also want to make sure that is not equal to end of file. If this first line returns an end of file, it simply means that there was no data in the file. And so if anything, what you can do is provide yet another statement back to the user saying simply printf error, or even a warning that says not sufficient data in %s, and of course that %s again is going to be none other than our file name. At this point, we can at least guarantee that we can read in one row of data. I'm also going to take just a second to put some punctuation down here to keep consistent. So at least we're able to read in one row of data. Now, what we would like to have happen is we'd like to continue reading in the remaining portion of the data. And that means that we can afford to go ahead and move or cut and paste our while loop inside our if statement. A little bit of cleanup, and we're almost there. Now, if you notice what I'm doing here in the first line in the if statement, I'm simply reading in the first line and I'm putting it into the X left and to the X right. And then in the while loop, I'm essentially repeating the process. And that doesn't really seem to make much sense. Instead, what I would like to do in the first line is read in the data and put it in the left variables, the X left and the Y left. And then inside of the while loop, I would actually like to take this second line and store it in my X right and my Y right variables. At this point, you would probably want to go ahead and make a quick change to your variables inside the print statement, or consider eliminating it altogether. The other thing that I would suggest that you do, if you would like to continue using the print statement, is to also put it outside the while loop and at least capture the data from your X left, or rather print the data from your X left and your Y left. In other words, your very first values out of your file. Once again, it's up to you if you wish to print the data out beyond your debugging. Now, let's think about how we're going to go about doing this. We're essentially going to need to find a length and a width of our rectangle. Well, if the length of the rectangle is viewed as the height, then essentially what we're going to use is going to be our Y left. So our Y left is the height of our rectangle, but then we're left with figuring out what the width of our rectangle is. Well, fortunately, the width is not that hard to figure out. It is simply our X delta. However, though, how do we get our X delta? Well, our X delta is none other than simply, I'm going to go ahead and put this down here on another line here. Our X delta is none other than our X left subtracted from our X right. Now, at this point, you should also want to consider doing some sort of error checking on your file. In other words, it would be a good idea to make sure that your values continue in increasing order. And so if they do not, then you might want to consider maybe notifying the user that you have some out of order data, or potentially even resorting the data. Okay, but we're not going to address that in this video. Instead, what we're going to do is we're going to go ahead and create another temporary variable called X delta, and that is essentially nothing more than a convenience variable. At that point, what we want to do is we simply want to use our height and our width, or our length and our width, and excuse me, multiply those two together to create the area current. So we're going to go ahead and throw in a couple of extra variables here. One is going to be a n current that keeps track of which line we are on. In other words, how many segments have we calculated the area for? And secondly, what we want to do is we also want to capture the area current. And whether you use uppercase or lowercase doesn't really matter. At this point, it would just be a good idea to go ahead and initialize these variables. And so we're going to start off by initializing our n current equal to 0 and our area current equal to 0.0. Now, and the idea here is that ultimately we would want to return back the total area from our summation. But if you go back to the instructions for this particular series, you'll notice that we also have a secondary goal of creating an output file associated with each one of our numerical methods. And particularly for this example, we also hope to print out a left rectangle.csv. And in that left rectangle.csv, we want to have the segment number, or n current. We have to have the value that we used for X left, the value that we used for X right, as well as the area current or the area for that particular block. Now, you could argue we could also capture the Y left and the Y right, and that's perfectly fine. We're just trying to keep consistent with our by file example. Now, from here, what we want to do is we want to go ahead and calculate our area current equal to the X delta times our Y left for this particular example. And then from there, we simply want to append it or sum it with our results. So results is equal to results plus area current. And at that point, what we want to do is we want to simply increment the segment count. So n current plus plus. Now, at this point, we've got to get that file output set up as well, because we don't want to temporarily store any of these values. We simply want to go ahead and write them to the output file. And to do that, we simply create a second file pointer that we are going to call output. And once we have successfully opened our input file and are reasonably comfortable that we are actually going to accomplish something, meaning that we've at least successfully read the first line out of the file, we can go ahead and use the output file pointer and fopen once again to open, and in this case, we're going to allow for hard coding, the left underscore rectangle dot CSV, and we are going to open it for writing. Once again, before we forget, particularly outside of our while loop, we want to go ahead and close our output file. At this point, this should now allow for us to go ahead and write directly after we make our calculations. So in this case, what we want to do is use our fprintf. We want to use our output file pointer, and we want to think a little bit about the format that we want to provide. In this case, it's going to be an index followed by 3 doubles. So for our format spec, we can have %d, %f, 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 separated by commas and followed by a new line. For our values, we simply want to have n current. We want to use our x left and our x right, and then also our area current. You can probably quickly see how you would go about adding more columns to your output file should the need arise. Well, at this point, the only thing we have left now is to play a little game with our x left and x right variables. And to understand what I'm talking about, let's take a look at our Excel sheet one more time. And we're going to zoom way in here. As a matter of fact, I'm going to try to focus on just the first few points. And so essentially what I want to do is I want to first assign x left to, or rather the value at the left to x left. And then I want to assign the second value to x right. At that point, I'm going to do my area calculation, and then I want to proceed to the next iteration of the loop. But for the second rectangle, my x left is essentially my previous iteration's x right. In other words, what I want to do as the last step of each iteration is simply to assign the value that was previously x right to x left. Likewise, I also want to assign the value of y right to my y left, so that now I have the left side of the next rectangle. And to do that, it's actually pretty straightforward. After we have completed our fprintf, in other words, after we've documented what we've done for our output file, we simply say x left equal to x right and y left equal to y Right. And what this does is this sets up the left side of the next rectangle. And if you notice, that's the reason why we had to change our initial variables inside of our while loop from x left to x right and from y left to y right. Because what we want to do is we want to capture the first value as the left side of the rectangle. And every time after that, when we pull a value out of the file, we simply want to pull it out and we want to assign it to the right side of that rectangle. And as I mentioned earlier, we've technically got a couple of extra variables in this particular example that hopefully will benefit us rather in the next example. So at this point, I'm going to go ahead and build it. And so far, so good. The only step then that we need to do is make sure that our switches are working correctly, and that can be done from checking it on the command line. So let's see if we've got this one working. So you'll notice here that I'm providing my numerical underscore demo.exe with my /p switch followed by my left rectangle. But specifically now I'm looking at by file and I want to provide with the input underscore o1.csv. If I hit enter, the first thing that you'll see is all of the data coming by, including our very first row, which we left in as an additional print statement. Once again, I'll leave this as optional for you to decide if you would like to include this or not. But more importantly, down here at the bottom, we have an area equal to 0.671650. Now, if you noticed when you first plotted this function right here, or rather we first plotted this data, you can almost guess what I used to derive this. So you can attempt to figure out what the function is, or you can also verify your calculations in Excel. But in this particular case, I can tell you that the function is actually 1 minus x squared. At what point you can go ahead and do the do the integration, and you will see that the exact value is 2/3, and we're pretty close to it. All right, now let's come back here and let's do one more thing. Go to Explorer, and what we're going to do now is we're going to go ahead and delete all of our output files from our previous runs, including our compare.csv from earlier. Make sure to not delete your input files of your input underscore one.csv, as well as your input underscore .2.csv. All right, and then once again, we're going to rerun our executable. And if you look, we should now have, again, our left underscore rectangle dot CSV. And if we drag and drop this into NetBeans, you should see our values, albeit with a considerable increase in the number of decimal places. So what you can do at this point is you can go ahead and actually, I'm going to take that back real quick. It appears as if we actually have a output problem. Let's see if we can play around with this real quick. And so if we take a look at our code, usually this type of error is associated with some sort of data type mismatch, or perhaps a overrun of memory from one variable to another. Now, we don't have any arrays inside this particular function other than, of course, our input file name. So at this point, then we would probably assume that we've got some sort of data type mismatch. And if you notice here, we've got our n current, which is supposed to be an integer. And I believe that if we come up here, we'll see that by accident, we have declared this as a double. And so in this case, what I'd like to do is actually switch this over to int, and let's see if we fixed the problem. All right, so we're going to go ahead and clear the screen real quick. I'm going to rerun it. And there we go. So it's quite amazing with C how something so minor as a data type mismatch, especially when you're within a particular type of variable. In other words, if we're dealing with integer values or numeric values, you wouldn't expect that big of an impact when accidentally trying to print a integer to a file. However, if you notice here, we now have the problem fixed. And more importantly, we started off with our input underscore o1.csv with 101 rows, and our left rectangle.csv has 100 rows. As we mentioned earlier, it essentially takes 101 pieces of data to create 100 rectangles. Now, if you want to, we can also go ahead and verify our sum here of 0.671650. And to do that, all we have to do now is to open our left rectangle, once again, in Excel. And in this case, what we're going to do is we're simply going to go ahead and we're going to sum this first or this fourth row. And you'll see that once again, we get the exact same values. Now, please note, do not make it a habit to leave your CSV files open in Excel, because if you do and you try to rerun your executable, you will not update your CSV file. So I'm going to go ahead and close this. I'm not going to save it. And at this point, then we should be ready to go to our other functions. So in this video, what we're going to do is we're going to focus in on the left rectangle by file. And then what I would encourage you to do is to take a second before watching the next video to see if you can figure out the differences between the left rectangle by file and the right rectangle by file. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.